Good morning, everyone. Good morning. Hope all is well. Hope everyone is doing all right.
Good morning.
Morning. All right. So, I think everybody's in there. So, ready to get into 4-3. I forgot to post your, if anybody was looking anyway, forgot to post sections 4-1, 4-2. So, I did that this morning before class. So, it's up there now. If anybody, was looking for that. Yep. Any general questions before we get into 4-3? How to get the best street. All right. Um, Better if I start this one from scratch. All right. So 4.3, modeling linear trends. The regression line. The regression line is the first thing we're going to discuss. It's a tool for making predictions about future observed values. And let me see how much your book goes into it. All right. It provides a useful way of summarizing a linear relationship. I don't want that to be red. All right, so the equation of a line, they go back a little bit to algebra, and they remind you the equation, the write-up of the equation of a line whenever you have y set up by itself or solved on one side by itself. It's in the form of your slope-intercept form, wherein the number that's sitting in front of x is your slope or your average rate of change. That's another way of looking at your slope. Uh, and then b is your y-intercept. But for stats, they write it a little different. So your book, write it in this form. But the same setup, whatever's sitting in front of x is your y-intercept. I mean, not y-intercept. Whatever's sitting in front of x is your slope, and the other number is your y-intercept. So they just did this to compare the differences between what you've seen in algebra to how you see it set up in this book. But once again, whatever's sitting in front of x is going to be your slope. Here it was m. Down here they call it b, and then the other number is your y-intercept. All right. Um, let's do this. Let me write it this way. All right, so the regression line in context. So we're going to look at this example, make sure we understand what a regression line is used for. Then we'll talk about how we can get it, how we can calculate it or find it. A college instructor with far too many books on his shelf is wondering whether he has room for one more. He has 20 millimeters of space left on his shelf. He can tell from the online bookstore that the book he wants has 98 pages. The regression line is, so I'll write down the regression line in a second. Just give you guys a chance to write. Let me put it over here. All right, so in the purple is our regression line. They wrote it with words instead of variables. So predicted with is the actual variable, but right now, like I said, since they're introducing it to you, they're writing it as a description versus just one variable. So the predicted with would have been a variable, and then pages would have been your other variables. So if you're talking about this, do I want to write it like that? I can. This would have been y, and this would have been your x. Like I said, since they're just introducing the regression line to you, they're using the description versus just a variable. All right. So the question is, will the book fit on the shelf? So this regression line is based on previous observations. Um, if you remember from last class, we found the correlation coefficient because we had these observations. We put it in easycalculation.com and we found the correlation coefficient. Same thing will happen with this. You have these observations that you have, put it in easycalculation.com or something of that nature, and then your regression line will pop up. And so you will be able to base, and I can write this up here. Your regression line is created based off previous observations, and based on your previous observations, you will be able to make a prediction about something, moving forward, or make a prediction on future observation. So, All right, so just pretty much just right what I just said there. So your regression lines are based on previous observations, and because of those previous observations, you are able to make a prediction on future observations. And going back, I just recognized I put 98 pages. It's supposed to be 598. So it's 598 pages. 598 pages. And that's what we're going to plug in right here into our equation, into x. We use what we are looking at or what we want to make a prediction on, plug that into our equation to get the prediction that we want. All right, so predicted width is going to be 6.22 plus 0.366 times 59. That's it, 59, 598. Multiply those together. In the order of operations, you do multiplication first, and then add. And that's what we're looking at our predicted width. So before we actually answer the question, any questions on what we've done up to this point? All right, so the predicted width for the book is 28 millimeters. And if you go back, he only has 20 millimeters left on the shelf. So the book should not be able to fit. That's a bookcase, right? You were talking about shelf. Yeah, shelf. All right, any questions on that before we go to the next thing? How you would use the regression line.
I have a question, Justin. The predicted width, it's for the book, right? 28 point. But we do have in his shelf just 20 millimeter. So how can it fit while the predicted is bigger?
I meant to write should not. I said should not, but I wrote should. I left off. I said should not, but book should not be able to. At least I thought I said should not anyway. But yeah, thank you for catching that.
Is A and B always going to be the same?
When you say the same, are you talking about these numbers?
Yes.
No, it's based on your observations. So your numbers will dictate what those numbers will be. Yeah.
So if we have an example, we're always going to have A and B provided?
No, well, we're going to get into that. Yeah, we're about to
Okay.
move forward. All right, so the book should not be able to fit. I can't believe I left off not. All right, but yeah, once again, thanks for that catch. Anything else before we go to the next thing? Make sure we're good. We're about to get into finding the regression line. All right. All right, so Well, I'll say, let me go ahead and write this first before I say that. So, yeah. All right, so let me do it like this. Okay. So finding the regression line, we already talked about your slope, which is B. Well, the way we find our slope is R times the standard deviation. Well, I'll do this, R times S sub Y over S sub X. Your intercept, which is A, is going to be Y bar minus B times X bar. And then our regression line is right here with Y bar equal, Y hat equal to A over A plus B times X. So we talked about last class about R and what that is. That's our correlation coefficient. And then X bar. X bar is the mean of our explanatory variable. S sub X is the standard deviation of our explanatory variable. Y bar is the mean of our response variable. S sub Y is the standard deviation of our response variable. And then Y hat, that's how we say that. It's a hat. That's our predicted Y. So difference between explanatory variable and response variable. I mentioned it last class, but I know we didn't go into deep detail. But this book actually kind of does it backwards. Like they talk about, your X and Y and stuff, but they don't talk about the difference. So until like the end of the section. So we'll cover it before we close out, but just going in order the way the book gave it. All right. Is everybody done with this? Can we scroll up? I want to be a little closer so I can write better. And that's good enough. All right. Everybody good before we look to do something with these things? These are formulas. All right. All right. I'm trying to see how I can shorten this problem up a little bit. All right, so I'm going to scroll up and lose some of the problem. So let me read it from this point forward, make sure we're all good. So a college in the U.S. used SAT scores to help decide which applicants to admit. To determine whether the SAT was useful in predicting success, the college examined the relationship between SAT scores and first year GPAs of admitted students. So I was trying to look to see what sentences to leave out. I found a few of them. So, it was longer than what I'm writing. Uh, students with, okay. Oh, didn't need that sentence. Sorry about that. Not the average GPA. All right, so in the middle, where did I do that? So right about here, we talked about the scatter plot, said it was 200 samples, 200, random sample size of 200 students. Says the scatter plot suggests a weak positive linear association, and then students with higher math SAT scores tend to get higher first year GPAs. So that's what was there in that, where the purple dots were. Well, like I said, I was just trying to cut back on how much we had to write, wanted to get to the information, give you a background, but then also get to the information. So then the average math SAT score of the sample was 649.5 with a standard deviation of 66.3. The average GPA was 2.63, standard deviation of 60, standard deviation of 0.58. And the correlation between the two was 0.19. All right, so the questions based on the information they gave us. Find the equation of the regression line. Note that X is going to be our SAT scores, Y is going to be the GPA, so they gave that to us. Y, just for future reference, Y is going to always be the one that you're going to predict. When I look at it, when we look at the differences between the two, that'll be a part of, the characteristics of Y. Y is always the one you're trying to predict. So if you know that you want to have your GPA, predict what someone's GPA will be if they score a certain score on the SAT, then SAT is going to be your X, which will explain why somebody would be getting this certain GPA. That's what you're using it for. And so that's what we're doing. We're allowing the SATs to predict what our GPAs will be. So whatever you're trying to predict will always be your Y. All right, is everybody written before we start answering these two questions? Hello? All right, so let's look at A first. What I normally do whenever looking at a word problem is I write down all of the given information first, all of the pieces of given information first. So, we're going to have X bar, S sub X. So the average of X, remember our SATs, our X. So we're looking at, 649.9.5, excuse me. The standard deviation was 66.3. Yeah. Average of my GPA was 2.63. Standard deviation of my GPA was 0.58. Then R was 0.19, I believe. All right, that's the correlation. So questions on a piece of information, how we pulled it, how we labeled it from the problem. Okay, so now to find the regression line, the way the homework is going to be set up, at least that's how the examples, I need to go recheck the homework. Probably it should be the same thing. They're going to ask you to find a regression line one of two ways. Either it's going to be this way, where they give you these pieces of information and ask you to just plug it into the formulas that we just introduced, or they'll give you the data set. If they just give you the data set, then that's where you go to easycalculation.com, type it in, and then hit enter. Now, I do believe there are programs wherein if you have these pieces of information, you can type it in and don't have to worry about using any formulas as well. You have to find them though. I just know with easycalculation.com, you just need each piece of data, and then you type in your data, and then it'll give you the regression line. So once again, if they give it to you like this, give you the average, standard deviation, correlation, and all that, then you would go ahead and use these formulas. And you can look for an app that asks for these pieces of information, and I'm pretty sure it's out there. But we're going to go ahead and do the formulas, make sure we're okay with using the formulas the way they're giving it, just in case you can't find that. But if they just gave us the data values, then you would go to the app and just type it in. All right, so the first piece, if you go back to how this is set up, here we go. First thing we want to find is our slope, because remember, part of it, the calculation of your intercept, there is a slope. So we have to find our slope first. That is R times S sub Y over S sub X. So R is 0.19. And we're going to multiply that times 0.58 over 66.3. And all of this matters. And that's why, when we get to X and Y, your order will matter. Which one you choose to be X, which one you choose to be Y. And 0.58, and that's going to be 0.001697. So when you're doing your calculations, you always want to go out 4 or 5. I'd say 5 or 6 decimal places to get the most accurate answer possible. You don't want to round this number to 2 decimal places or 3 decimal places. Problem is because the more calculation you do with something that you've already rounded, the further away you get from the actual answer. So you want to go about 5 or 6 decimal places while you're doing your calculation. And then at the end, maybe round to 2 or 3, depending on what my math lab is asking of us. But while you're doing your calculations, you do want to round out maybe 5 or 6 decimal places. So just throwing that out there. All right, yeah. All right. So questions on what we did there. So all we did was plug in according to the pieces of information that the problem gave us. So your book, sometimes it depends on how they position the wording. And sometimes they use the symbols for the regression line. Sometimes they'll do like they did when they gave us that first problem wherein they'll use words to represent those variables. So just make sure you're paying attention to what they're doing in the problem. I think this book likes to lean towards doing this, wherein they write predicted GPA instead of Y hat. And then, we X represented our math SAT scores. So they'll put SAT right there. Also make sure that you hold true to, like I said, your final answer. When they put a box right here and box right here, they'll tell you how many decimal places they wanted you to round that to. So I'm looking at the answer here. They got 0.0017, even though right here we went further. But you do that when you're doing your calculation. But when you put your final answer in, they will tell you how far they want your decimal to be out. So just make sure you pay attention to those, details when you go about putting in your final answer. All right. Anybody have any questions on A before we look at B? All right. So B, do I want to let it be purple? I'll probably go back red. So B, it says use the equation to find a predicted GPA of a person with an SAT score of 650. So that means X is going to be 650, and we want to know what would that predicted GPA be. So we plug in 650 for that GPA. And that'll be our answer, 2.635. All right, any problems with that? All right. All right, so the next piece in this section is looking at, like I mentioned before, choosing X. I don't know why I put it deep. Yeah, choosing X and Y. And this notice for me, that should be, I think it's 4.1. Can I go off this page? Everybody good? All right. All right, so here we go. The differences between our explanatory variable and our response variable. So your explanatory variable explains the value of the response variable, and your response variable is going to be explained by your explanatory variable, but it responds to your explanatory variable. So explanatory will always be X, response will be Y, and then all of the other differences that come along with being X versus being Y, domain versus range, input versus output. Remember, we plugged in the value that was for X, and then we got out the value for Y. So input versus output. Your explanatory variable is independent when your response variable will be dependent because it depends on your explanatory variable. Your explanatory variable is horizontal axis, response is your vertical axis, and then in the purple you see that goes back to what we were talking about, your predictor versus your predicted. Whichever one you're trying to predict will always be your response variable. All right, any problems with this? Everybody still copying? All right, so let me see, I think that is the last thing out of this section. All right. I think we're good. And just to revisit, explanatory versus response, when we go back to our golf club golfer. As a matter of fact, let me see, do we got a good one that I can use to, no, it's okay. So we don't have to go back to the golfer, we go back to the guy that had the books, the instructor had the books. Notice he was using the pages of the book to explain the thickness of the book. So the pages would have been X, or your explanatory variable, and your Y, your response variable, would be the thickness of the book. So let's look at, well, any questions on 4.3? All right, I think we are good. Sorry about all that noise. If it sounded like a lot of noise, I don't know if that was or not. So let's look at 4.4 and get ready to close this out. 4.4 is just a few points that they want to make about the regression line, evaluating the linear model. All right, so 4.4, evaluating a linear model. They start off with pitfalls to avoid. First one, don't fit linear models to nonlinear associations. So basically what they're saying here is that uh, regression line is only for linear models. So if you were to use your regression line for something else, remember we talked about different relationships that were not linear. Your regression, excuse me, your regression line would not be a good measure or a good way to predict a value in a nonlinear model. So your regression line is only for linear models. Correlation is not causation. We talked about that one already. Just because there is a strong correlation does not mean that that is the cause. Or just because there's a strong association does not mean that is the cause for those things occurring. Beware of outliers. We talked about how your correlation is affected by outliers. So that means if your correlation is affected by outliers, that means your regression line will be affected by outliers. Because remember, part of your regression line calculation is R, which is your correlation coefficient. So be aware of outliers. Aggregate or aggregated data. That's just another way of saying groups of data. So basically, it's just saying that a lot of times regression lines are used for groups of data. So, and then don't extrapolate. Um, yeah, don't make predictions. They say range. I'll use range. So don't, and then so the last one, don't extrapolate. In other words, don't make predictions beyond the range of data. Make sure the data that you're using applies. I mean, the prediction you're trying to make applies to the data that you have based your observations on, or the equation that you base your observations on, and don't go beyond that. So one of the examples that they used was, if you're looking at the heights of kids by a certain age range, let's say 9 to 12, you don't want to take that information and try to predict, teenagers because, with puberty and different things like that, their age ranges will probably, not probably, but not age ranges, but their height ranges differ, than those who are younger. And so that will be another group of individuals that you will have to look at and make sure that you're not going beyond your range of data. So those are just 5 things that they say look out for. All right. Last thing in this section. Coefficient of determination. Let's see if we want to use these notes. I'm coming back to it. Yeah, I'll probably just use these. Okay. All right. Anybody still copying anything before we go to coefficient of determination? All right, so coefficient of determination, it determines the proportion of total variation in the response variable that is explained by the regression line. So it basically tells us how reliable our regression line is. It is the correlation coefficient squared. All right, denoted by capital R squared, even though it's lowercase r that we are squaring. They denote your coefficient of determination by capital R squared. All right, it's between 0 and 1 inclusive. So if your coefficient of determination is 0, the regression line has no explanatory value. In other words, it's completely unreliable. If it's equal to 1, then the regression line explains 100% of the variation of the response variable. So that means it's 100% reliable. So every time you use it, you're going to predict it accurately. All right. All right. Anybody still copying what's in black?
Hold up.
Uh-huh. All right. So
Okay.
just, all right. Sounds good. Sounds good. I wasn't going to scroll up. I was just going to start talking. So I still had you. Thanks. Looking at this example just to make sure we're okay with, how we would find it and then what it means when we have it. It says determine and interpret the coefficient of determination for the club head speed versus the distance. So I don't know if y'all gave you guys that information, but that, we don't need it for this one. Just making sure that we're okay with the steps. So they would have gave us a set of information and we would have went to, once again, like I showed you last class. Yeah, I showed you that club head speed versus the distance. And we went to easycalculation.com. And so first step is always to find your correlation coefficient. So you got to have, that to square it. Then to find the coefficient of determination, all we're going to do is square. Going to square that correlation coefficient. So we found lowercase r to be 0.939. Once again, we get that from going, we have our data set, then we go to an Apple website or something of that nature, To find the correlation coefficient, type in our data values, hit enter, and we get 0.939. Then to find the coefficient of determination, you square it. Squaring that gives me 0.882. And then if I wanted to write it as a percentage, move the decimal 2 places to the right. So I get 88.2%. So before we go to step 3, any questions on what we did? All right. So the interpretation of what that means for us. See, I got another, yeah. So 88.2% of the variation in distance is explained by the regression line. 11.8%, and where we get that from is we subtract 88.2 from 100, get 11.8% of the variation is explained by other factors. So basically what that means is that the regression line has an 88.2% reliability. And those other factors could easily be, if you're outside, could be wind resistance, maybe the guy when he swung the ball one time, he swung it wrong a little bit or twisted his hip one way that he normally didn't do or something of that nature. So you're talking about other factors that can explain why the prediction, it wouldn't be as accurate as it could be. Pretty sure if he was a robot doing it, it would be more precise or more, more reliable because remember, it's based on previous observations. So it'd be based on all of the observations experienced before the regression line was created. All right, questions. All right, I think we are good. There's one more. Association with linear largely. We should be fine. Yeah. So, any questions? Everybody good? Everybody straight? All right. So that is it for chapter 4. Next class, I will open up the floor for questions first before we do anything else. So if questions are generated over the weekend or, just want to, talk about a certain thing that you didn't quite understand after looking at videos or some of you wrote down in your notes, then the floor will be open for you guys to ask anything. And then we'll look to see where we're going to move on to next. All right. Any questions before we let out today? Making sure we're good.
Thank you. Have a good day.
All right. Thanks. You do the same. So you guys take care. Have a great weekend, and I'll see you next week.
Professor, I'm sorry. Are you after today? Are you posting the 4.3 and 4.4 on Pearson, or is it like coming up like later on the weekend? I just wasn't sure.
No, I'll get it in there hopefully before the day is out. Yep.
Oh, okay. And then is the test for 3 and 4 coming up on the weekend, or is it like next week?
So I'll probably post that one like I did the first one. And then we'll look to maybe take our third test proctored.
Okay, thank you.
All right, not a problem.